Hello Math 7, we're going to do 2.3, lesson 2.3 in comparing and scaling, and we're going to start out with filling in some vocabulary words. So first vocabulary word we're going to fill out is proportional relationship. So a proportional relationship has a constant rate of change going through the point 0, 0. Okay, then constant of proportionality is the coefficient in the equation y equals mx. Okay, and we can also call that the unit rate. Which brings us to our next word, which is unit rate. So unit rate is a rate in which the denominator is 1. So let me zoom out so you can get those three. Okay, so now we're going down to 2.3. So page 16 in your journal, in your comparing and scaling journal. So lesson 2.3 is called Finding Costs, Unit Rate, and Constant Proportionality. Our focus question, so our question we're trying to answer today, is how can you find a unit rate in a description, an equation, a table, and a graph? So quite a bit going on here with that. So Fresh Foods has oranges on sale for $2. We want to be sure we label our answers with proper units. So what is the cost per orange? So cost per orange. So we know, so we're working with oranges. So oranges and money. And we know that 10 oranges cost $2. And so what we want to know is how much one orange costs. So if we do some cross multiplying here, 10 times x would give us 10x. 2 times 1 would give is 2. Divide both sides by 10. Now look, this is 2 divided by 10, not 10 divided by 2. The answer is not 5. So if we put that in the calculator, 2 divided by 10, that is actually going to give us 2/10, right? Sounds the same, doesn't it? But we want to write it as a decimal. And why is that? Because it's money. So the cost of 1 orange is 20 cents per orange. So how many oranges can you buy for $1? So we could set up a whole nother proportion, doing oranges over money, right? 10 oranges for $2. So how many oranges can we buy for 1? And then solve for x. So 2x equals 10. Now this one is 10 divided by 2. So this one, x, does equal 2. Or not 2, 5. So 5 oranges. Alright, the next one, complete the table below. Well, so 10 oranges for $2. So $1, we just found that, is 5 oranges. 1 orange, costs, oops, that didn't work very well. Costs 20 cents. So 20 oranges would cost $4. 11 oranges would cost, well, $2.20. And then 260 is how many oranges? That's 13. All right, number 4. How does finding a unit rate help you answer questions such as, how many oranges can you buy for $5? And how much do 25 oranges cost? So finding a unit rate, so to answer the first one, how many oranges can you buy for $5? Well, we can divide $5 by the unit rate, right? And that would give us the answer. And then the second one, so how much do 25 oranges cost? Well, that one, we can multiply $25 by the unit rate. All right, number 5. The equation y equals 0.2x relates cost y to the number of oranges x. What does this equation tell you about the relationship between the number of oranges and the cost of oranges? So this tells us that tells us 1 orange costs 20 cents. Identify the unit rate from this equation. Explain how you found the unit rate. What information does the unit rate give you? Well, the unit rate, right? We learned in our definition that the unit rate is that number in that equation, y equals mx. So in this one, that 0.2 is that m in the y equals mx. So identify the unit rate. Well, the unit rate is 0.20. Okay, next part. Explain how you found the unit rate. Well, we found it because we know it's the coefficient in that equation. Hold on, I'm spelling that wrong. Okay, let's zoom in a little bit so we can have it a little bit neater. There we go. So it's the coefficient in that. And then what does it tell us? It tells us how much one orange cost. So cost of 1 orange. How does the constant of proportionality relate to the unit rate? Well, they are the same. They're the same thing. Only difference is a unit rate usually has labels where a constant of proportionality doesn't. Whoops. Okay, next page. Answer the following questions. Graph the equation from question 5 on the coordinate plane. Show values of x from 1 to 20. Well, what was that equation? Equation from question 5. So let's go back up here. Question 5. Y equals 0.2x. We're going to come back down here and let's write that. Y equals 0.20x. So let's start by labeling our graph. So along the bottom is going to be our number of oranges. And then across the side here, there's going to be our cost. Whoop. So we are supposed to show values of x from 1 to 20. And so there are enough boxes here that we can go by ones, but just so our labeling is a little cleaner, we're definitely gonna start at 0, and I'm only gonna put every 2 in. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then up the side, so the cost, we're gonna start there. So 1, 2, 3, 4, and then 5 is all the way up here. So we know that 5 oranges cost $1, right? So each of these are $1. So 5 oranges cost $1. And you know, I did my labels in this purple, so let's do our actual graph in a different color, so that way we don't confuse our little tick marks for where our numbers are. Okay, so 5 oranges, so 5 was down here, so I'm gonna start down here, so 5, so I'm going over 5 for oranges. 5 oranges cost $1. Okay, so 10 oranges cost $2. So then 15 oranges are going to cost how much? $15 oranges are going to cost $3. Oh, that's my... Okay, so 20 oranges cost $4. And 0 oranges cost $0. Probably should have done that one first. And so then what I'm going to do to draw our straight line is I'm going to start down here at 0. And remember, to draw a straight line, you touch on it and then you hold it, except for we want it to be on 0. Nope, still don't like that. Okay, let's get rid of all that. There we go. And then we bring it all the way up. Then we want to bring it the best we can through here. And draw an arrow. So there's our line. So y equals 0.2x. So 20 cents per each orange. Okay, so how can you use the graph to find the unit rate? Well, we just look at when x equals 1. So when x equals 1, y is 0.2. How can you use the graph to find the constant proportionality? Same thing, right? When x equals 1. So when x equals 1, y equals 0.2. Okay, so that was our beginning part, so finding the oranges. Now we're gonna go and we're gonna find some unit rates. So Nora Lee's car uses 20 gallons of gasoline to go 600 miles. Write a unit rate that demonstrates the relationship of miles per 1 gallon. What does this unit rate mean? Okay, well, we want to know per 1 gallon. And a unit rate, right, is a rate in which the denominator is 1. Okay, so the denominator is 1, so that means that we want per 1 gallon, so that means we need gallons to be in the denominator. So we're gonna do miles over gallons. And so our unit rate, not our unit rate, but our rate that they give us was 20 gallons of gasoline. Whoops. And she could go 600 miles. So 600 miles on 20 gallons of gas. And so we want to know how many miles does she get for every 1 gallon? So we could set up and solve this proportion, or we could have just done 600 divided by 20. So what's 600 divided by 20? $30. So she can do 30 miles on 1 gallon. So that's some pretty decent gas mileage there. And so what does that mean? What does the unit rate mean? It means for every 1 gallon, $30 miles are driven. Okay, next part. So we're still talking about Nora Lee's car uses 20 gallons of gasoline to go 600 miles. So the graph below shows the relationship between distance y and gallons x of gasoline. At what point do you see the unit rate appear on the graph? So looking at the graph here, where do we see the unit rate? Well, it's when x equals 1, right? So when x equals 1, right here, so we go up and find x, so we see it right there. So what equation relating to y and x does the graph represent? Remember, our equations, we write them in y equals mx form, right? Where m is your unit rate, and so what's our unit rate here? It was 30, so then all we have to do is plug it in. So y equals 30x. So which coordinate pair represents how far Nora Lee can drive on 1 gallon of gas? Well, we just found that, didn't we? When x is 1, y was 30, because she can go 30 miles on 1 gallon. Which coordinate pair represents how far Nora Lee can drive on 0 gallons of gas? Well, if she has 0 gallons, she can go 0 miles. Okay, Josh used the proportion 600 divided by 20 equals x over 4 to find the number of miles Nora Lee's car can travel on 4 gallons of gas. Lisa says she can use a unit rate. Do you agree with Josh or do you agree with Lisa? Explain. Well, which one is correct? Well, both are correct. So Josh's proportion is accurate. And Lisa is using the unit rate. What other strategies can you use to find the number of miles Nora Lee's car can travel on 4 gallons of gas? Well, we can make a table, right? So we can make a table or a graph. Okay, next part C. Several students wonder which is a better buy. A 40-pack of pencil top erasers for $2.82 or a 2-pack of pencil top erasers for 12 cents. They use different methods to arrive at an answer. So we're starting here with Courtney. So Courtney says, compare the 2 unit rates to determine which unit rate is cheaper. And so then she goes along to say, okay, 282 divided by 40 equals x over 1. And so she gets roughly 7 cents per eraser. Okay, or the 2-pack is 6 cents per eraser. So she's saying the 2-packs have a cheaper per eraser price. Okay, so Elliot says, if I buy 40 of the 2-packs of erasers, the total cost will be 40 times 12 cents, which is 4.8, or $4.80. That is more expensive than spending $2.82 for a 40-pack of erasers. The 40-pack is the better deal. Okay, so already they're disagreeing. So Julio, if a 2-pack costs 12 cents, then 20 2-packs would have the same number of erasers as the 40-pack. 20 2-packs cost, well, 20 times 12 cents equals 2.4 or $2.40. So since a 40-pack costs $2.82, the price per eraser of the 2-pack is cheaper. And Kimmy, if a 40-pack costs $2.82, then half of the pack, 20 erasers, should cost $1.41. 10 2-packs, also 20 erasers, should cost $1.20. this is cheaper. The price per eraser is cheaper than using the 2 packs. Okay, so who is correct and why? Well, what we might have to do first is maybe we should just do our own math. Right? Let's do our own math and then compare our math to theirs and see if they were right. Alright, so we can get either the 40 pack for $2.82 or the 2 pack for 12 cents. So let's find our unit rate. So remember to find a unit rate. So unit rate for the 40 pack. So I can buy 40 for $2.82, and so I want to know how many can I buy for 1. So 40 divided by $2.82. Well, that says 14. Nope, that's not right. We need to do 282 divided by 40. Okay, so we get 7 cents. So we're gonna scratch that. I had the X in the wrong spot. See, I make mistakes just like you guys do. Okay, so we needed to do 282 and 40, and we wanted to know 1 was how much. There we go. So 7 cents. Then our other one is it is 12 cents for 2 erasers. So how much would 1 be? So 6 cents. Okay, so now that we've done our own math, we can see, okay, well, Courtney's math matches ours. Right, so she got 7 cents per eraser for the 40 pack and 6 cents for the other one. So let's just put a check mark. So she found the unit rates, and hers were the same. Elliot said that the 40 pack was the better deal. Well, nope, but we know the 2 pack was the better deal because that's what we found. So let's just cross Elliot's off. Julio says that the 2 pack was cheaper. Well, that's what we found. So he's correct. And Kimmy said that the 2 pack was cheaper. So she is also correct. So now it's asking us which of these methods are correct and why. So now we just have to explain, why are they correct? Well, we can start with Courtney. So Courtney is correct because she used a unit rate, just like we did, right? So she used a unit rate to compare. And then, so Courtney was right. And then Julio was right. because she found the cost. Hold on, didn't I say he a while ago? I said he. So he found the cost of the same amount of erasers. And Kimmy is correct because she also found the cost of the same amount of erasers. Okay. So you have to remember when you're comparing, right, you have to keep your ratios consistent, right? You have to keep them proportional by multiplying both numbers, right, by the same scale factor. Okay, so we're answering our focus question. So how can you find a unit rate in a description, an equation, a table, and a graph? So we're going to start with how can we find it in a description. So we have to start by, we have to start by writing a rate from our given information, right? So write a rate with the given information then create an equivalent rate with a denominator of 1. Oh, that doesn't look like a very good 1 now, does it? Maybe we should just write the word of 1. So how can you find it in a description? Well, we first have to take our description and find a unit rate. Then we have to create an equivalent rate to find an equivalent rate with a denominator of 1. How can you find a unit rate in an equation? Well, our equation, we want our equation to be in y equals mx form, and the m is the unit rate. Okay, how can you find a unit rate in a table? Well, we see tables two different ways. We see tables horizontally like this, and we would start with 0, 0, and then we would have 1, and then whatever y is here is your unit rate. So what is y when x is 1? Or sometimes we see that table like this. 0, 0, 1, and then unit rate. Okay, and then how can you find a unit rate in a graph? Well, kind of the same as a table, except for like when x is 1, y is your unit rate. Okay, so that is how you find your unit rate in a description, in an equation, in a table, and in a graph. Don't forget to do that daily practice. Have a great day. I'll see you guys later.